Good morning, good afternoon, good evening. Today I'm going to explain the types of combustion chambers. This is going to be a brief explanation, but I hope you grasp something from it. A combustion chamber is a space in an engine where fuel is mixed with air and burned to generate the energy that drives a vehicle, for example. Now, I think to help you visualize what I'm talking about, think of a kerosene lamp. My parents had two kerosene lamps. This exact same color as shown in the image. They don't use them anymore because electricity, but we still have at least one of them is still around. So the space in which the wick burns, the space in which the wick is alight, is the combustion chamber, the space surrounded by the glass wall where the burning of the fuel, in this case kerosene, is happening. That's our combustion chamber. Now, largely, if we were to group them into larger groups, the different types of combustion chambers will have internal combustion chambers and external combustion chambers. These words, internal, external, are self-explanatory. Internal, the combustion chamber is part of the larger engine. External, it really isn't. It's outside of it. Now, if you've watched an old train movie, maybe there's a hijacking, it's a train hijacking movie, they will usually they sometimes show a clip of someone shoveling coal into a fire on the train. So that is an external combustion chamber. The area with the fire that they're shoveling coal into is an external combustion chamber. Now, I think let's focus more on internal combustion chambers. We have combustion chambers for gas slash petrol engines. These engines use spark plugs to trigger the burn. The shape of the roof of the cylinder dictates how the fuel mixes. I don't know if I read it earlier. Here it is. I don't know if I read it earlier, but the combustion chamber types depend on engine design, how fuel is injected, and the application. Right, so engine design and how fuel is injected. So for gas slash petrol engines, the engines use spark plugs to trigger the burn. The shape of the roof of the cylinder dictates how the fuel mixes. There is hemispherical, shaped like an upside down bowl. It's highly efficient because the spark plug sits right in the middle, meaning the fire doesn't have to travel far to burn all the fuel. There is wedge, shaped like a sloped roof. It pushes the air fuel mixture into a tight bunch near the spark plug, making it very budget friendly. There is pent roof, shaped like a roof of a house with 4 or 5 sides. It allows for more valves, which help the engine breathe better and is very common in modern cars. Now, this is the diagram just so that you can see the combustion chamber that we're talking about. Hemispherical, pent roof, wedged. I think there's an extra one there, which is pancake. Now, you can also think of combustion chambers for diesel engines. Diesels do not use spark plugs. Instead, they squeeze the air so tight it gets extremely hot, then spray fuel directly into that heat. We have open, which is bore and piston combustion chambers. The top of the piston is scooped out like a ball. The engine swirls the compressed air rapidly into this ball before the fuel is sprayed in, making it highly efficient for big, heavy-duty engines. Then we have pre-combustion combustion chambers. Instead of spraying directly into the main cylinder, the fuel is sprayed into a small separate side chamber first. The initial fire starts here and shoots out into the main piston. It runs smoother and quieter, though it uses slightly more fuel. So I'm looking at my screen, you're looking at your screen. The image on the left is the open combustion chamber with the scooped out piston, and then the image on the right is the pre-combustion. I think that spherical cavity there is the separate chamber for combustion to initially take place in. Now we can also discuss for jet engines and gas turbine engines. These engines are the engines used in aircrafts, right? Unlike piston engines that explode fuel in bursts, jet engines burn fuel constantly. Now the types are, we have the can combustors. Think of this as a row of individual sausage-shaped metal tubes arranged in a circle. Each tube has its own fuel nozzle. We have annular combustion chambers. Instead of separate tubes, this is one continuous hollow metal ring that wraps around the engine. It's lighter, uses less air pressure, and is a standard design for most modern jetliners. We have can annular, which is a hybrid between the two, a hybrid between annular combustors and can combustors. It features separate tubes like the can combustor grouped together inside one continuous outer ring. It has all the best features of the can combustor, but the simplicity of the annular one. Here are some diagrams to better help you see the jet engine combustion chambers. If you look at the top left image, the first one in that top left image is the can type. The middle one is the cannular type, which is a hybrid of the can and the annular, and then the last one is the annular type. Now, rightmost image is a cross-sectional diagram of the annular type combustor, and our left bottom image is more realistic schematic of the can type combustor. I hope this video has helped you learn about the types of combustion chambers. Thank you for joining me today, and have a good day.